Guys, I wanted to make a video about solving two-step equations. So I'm going to push this video out to both my 6th and my 7th graders. 6th graders, just know that I might in this video take you past where you need to be right now, but it's good information and it's things that could help you when the math gets harder. So with solving two-step equations, and really this is just solving equations, we have some guidelines we can follow, some rules that we need to follow, and then in this, it's going to be some suggestions of things that you can look for when you're not quite sure what step to do first, second, or third. So that's why this is specifically solving two-step equations, because with solving one-step equations, there's only one step, so you're not going, which should I do first? So let me just first start by showing you some kind of simple one-step equations. So we have things like this, and we have things like this. Okay? So here's kind of how I take my students through solving equations, is our goal is to have x by itself. And when we say that, it means that our goal is to have something like this, x equals 2, x equals negative 2, or even like this, okay? Notice though, in all three of those examples, it doesn't say negative x. We don't want to know what negative x equals. We want to know what x equals. And I'm going to show you before the video is over how we can account for that. So right now, our goal is to have x by itself. So what that means is we are only looking at the side with the x, and we're going to make a decision by looking at this side, and whatever we decide to do, we're just going to do to the other side. And you will slowly unravel the problem until x is by itself, and you will have an answer on the other side. Okay, so I'm about to write the rules, and so what I'm about to show you might make more sense once you see the rules. But this is how I would talk someone through this problem. What is keeping the x from being by itself on that side of the equal sign? And the answer is a negative 3. So what I would ask you then is, what is the opposite of negative 3? And you would tell me positive 3. Okay, so that is what we are going to do to this side. And if I do it to one side, I do it to the other side. Notice sides of the equal sign. Okay, so what I do is I bring down the x. Negative 3 and positive 3 cancel. That's the whole point. I'm trying to undo that side and move everything to the other side. I bring down this equal sign. I like to tell students it's like a fence. You can't just move your fence. It's got to stay where it is. And that's why in this math, we're going to work all the way down our papers. We are not going to come off to the side. Okay, and if I see math that you're doing that, I'm going to ask you to redo it, because I want you to get really good habits right now while you're practicing the easier problems. So later when it's harder, or you're in 8th grade, you have these good habits and you can accomplish solving the harder problems. So we bring the equals down, and now this is our problem. We're actually doing 7 plus 3, 10. X equals 10. We've reached our goal. Just like one of those, it says x equals a number. Now, what we can do is plug that 10 back in for x and evaluate the expression. So I'm going to write 10. I'm going to come back to the original expression. I'm going to put 10 where the x was. I'm going to write the rest of the problem, and this is how you check yourself. 10 minus 3 is 7. That equals 7. I know I found the correct answer. X equals 10. Okay? So that is what we would do with like addition and subtraction, is doing the opposite. If it's a negative 3, we're going to do plus 3. If it's a plus 3, we're going to do negative 3 to both sides. Remember, negative and minus mean the same thing. Okay? It's the same thing. So you'll hear me say it both ways sometimes. Let's look at this side. So if I asked you the same questions, what is keeping the x from being by itself? The answer would be a divided by 3. So we want to do the opposite and multiply both sides by 3. I like to write it up here, times 3. Because when I do that, 3 over 3 leaves me 1 and an x, and we know 1x is really just x. So another way of thinking of it is the 3's cancel each other out. Okay, they don't cancel to 0, they cancel to 1, but we know 1x means x. And if I do it to one side, I do it to the other. I keep my equal sign. 7 times 3 is 21. And if you look, plug that 21 back in right there. 21 divided by 3 is 7. So I know I have the correct answer. Okay, so these are the type of one-step problems that I am talking about. And then I will show you two-step problems, but we're going to write some rules, okay? Now, I really, really want to stress to you, when you're starting these problems, you should have the rules in front of you, because there are going to be times that you're not sure what to do first, and if you read through these rules, one of them will kind of help you remember, oh, okay, I'm going to do this. So here are our rules. Now, these are things I'm going to say to you when I'm trying to help you get through the problem. Some of them will make sense once you see them being used. So for now, write them down, get them somewhere good in your math notebook, and when I start showing you some of the other problems, you will hear me reference these rules, okay? So here is a rule. I always switch the order when I do these, so there's no rhyme or reason to the order. So one rule, what you do to one side, you do to the other. You've probably heard that, but we're going to write that down. That is very important. And when I say what you do to one side, I mean to the entire side. So don't write this, just watch. If I decided in a problem like this, I wanted to divide by 2, which would help me in this problem. I don't just divide this by 2, but I divide this by 2, and this by 2, and this by 2. And if you notice, 2 over 2 leaves me x. 4 over 2 is 2. Don't move your fence. 6 over 2 is 3, and 8x over 2 is 4x. So you notice I made all my numbers smaller. But that's what you do to one side, you do to the other means. It means you do it to everything. Now, notice, as a side note, let's say I want to subtract 2. Well, can I really subtract 2 from an x? No. So in this case, I can only subtract 2 here and here, because I also can't subtract 2 from this x. So when you're adding or subtracting, you can only do numbers with numbers, x's with x's. Okay, so with division, I can divide everything by 2. But with addition and subtraction, I can only do numbers with numbers. So please remember that difference. And you'll see it kind of in the moment if it's a little confusing to you. So let's go ahead and write this rule. What you do to one side, you do to the other. What you do to one side, you do to the other. That is very important. That is a rule you cannot break. Number 2, if you are ever uncertain what to do first, second, or third, okay? So not one-step equations, because they're literally only one step, but 2 steps or more. If you're not sure what to do, one way you could maybe sort through it is when we are solving equations, we do PEMDAS backwards. Backwards, I know, crazy. But think about it, we're undoing the problem, we're using opposites. So PEMDAS backwards is how we would undo the problem. So if you're looking at a problem and you have multiplication and you have addition and subtraction to do, you want to do the addition and subtraction first because we're doing PEMDAS backwards. Okay? This is more a suggestion. There are ways, if you kind of do the order wrong, to fix it later, but if you stick to this as really something you look at right before you start the problem, it will help you solve the problem easier. Okay, so we're going to say do PEMDAS backwards. Okay, and I think that SAD MEP. SADMAP. I guess if we use GEMDAS, it'd be SADMAG. So that probably makes more sense. Okay, so do PEMDAS backwards. A third rule. We have something called use opposites. And that's what I was saying earlier, where I said, what is keeping the x from being by itself? A positive 3. Okay, so we're going to do the opposite. -3, -3. So we're going to write opposite operations. Okay, if it's a +3, we -3. If it's a divided by 2, we multiply by 2. If it's multiplied by 2, we divide by 2. So you're constantly looking at what's in the equation and then doing the opposite of it to undo the equation and get to your answer. Think of it like a puzzle. Opposite operations. Now, what we've been doing is combining like terms. But combining like terms is only when they are on the same side of the equals. Okay, I'm about to erase the top rules because I want to talk about number 4. So if you need to, pause the video. So, combining like terms, let me see, looks like this. So this is combining like terms. Maybe on one side of the equals, I have 2x plus 3x plus 1 equals 10. Okay, so I know that 1 and 10, because they're both numbers, they're like. And I know that 2x and 3x, because they're both x's, they're like. But 1 and 10 are on 2 different sides of the equals. So to do that, I have to use step 3 and use opposites. But 2x and 3x are on the same side of the equal sign, so I get to just say 2 plus 3x is 5x. That's combining like terms. Now, 1 and 10 need to be together because they're keeping that x from being by itself, but because they're on opposite sides, I have to use opposites. And this is a part of the problem that you come to often when there is a number in front of the x equals another number. At this step, because it's 5 times x, we want to divide by 5. And I like to put it like this. The 5 and the 5 canceled 1x, which I'm not going to write the 1, equals, and I have my answer. I don't have to do the division. I can just reduce if I can, and if I can't, there's my answer. I'm going to stop this video now that you have the rules, and in the next video, I'm going to show you some 2-step equations, okay?